Hello. Good afternoon, everyone. Thank you for staying back. I know this is the last two sessions before you go home. My name is Steve Sofian. I'm covering the public sector in Singapore and ASEAN, mainly Singapore governments, GLCs, what have you. So for today's session, it's an architectural session. We'll review the services in terms of how do you do microservices on AWS, and how does it differ from the traditional monolithic architecture and service-oriented architecture. The next thing I will cover is basically some of the challenges that you will see in terms of when you do a microservice architecture at scale. And lastly, we'll see in terms of how we can do that on AWS. First and foremost is that what are microservices? I'm not going to read through this. I will pick three key terms. One, it's small, it's independent, and it's decoupled. So these are the three key characteristics that you will have or you will find in a microservices architecture. First, this is a very traditional architecture that I hope that you have gotten this passed by you, which is the monolithic architecture itself. A holistic application basically is developed as a single unit, so on a shared infrastructure. So all the components, all the functions is built into a single component. It's hard to deploy, and a lot of times when a deployment fails, pretty much you have to roll back the whole thing, right? And so this makes deployment very risky, and you have to go through a lot of centralized approval and coordination. Many of the organizations today have seen the negative impact of this architecture itself in terms of the impact on how fast you can or how agile you can build an application. So let's get past this. Next is one of the most popular service-oriented architecture approach. So this is where the components are decoupled. In this diagram itself, you see that the architecture is basically split into three particular tiers. It's commonly known as the N-tier architecture. So the client application or the user front-end experience is being delivered in the presentation tier. And a core set of business logic resides on the server as your logical tier. And any data that's required to be persisted to a data store resides in your data tier. So this makes it in terms of how you scale, in terms of you can scale different components on the different tier itself. So you need to scale on the server side or the database, you can scale it independently. And for the last few years, the microservices architecture has become very popular today. And very often than not, you hear like the term containers. So this is very similar to the service-oriented architecture. It has the same tenets and all the value proposition that a service architecture approach provides you. However, the components are broken into smaller pieces, so that it's a single modular web services, such that it still reaps the benefits of SOA. So when you break it up into small components, so you have a smaller development team that is very specialized on delivering a small piece and very functional piece of code. So you are just very focused. You have smaller teams. You can deploy faster. You can develop faster. To some of you who might be new to containers, when you talk about microservices, you will hear about containers. So on your right, on your left, basically you see the traditional in terms of Hyper-V or VMware or virtualization. So on your right, these are the containers. The only difference is that containers does not have to care about the operating systems. It talks to the operating system through an API. So there's no embedded operating system in a container itself. So how do you deploy containers on AWS today? Well, we already support Docker data center on AWS. What you have to do basically deploying the Docker data center on EC2 or what have you, or you might even be looking at Docker Swarm. All these are being supported today. So now let's look at some of the challenges of running microservices. First is resource monitoring. When you have a large fleet of servers, this is, for example, 3 AZs in a particular region and a bunch of EC2 instances. It will be very hard for you to manage, or practically impossible, when you grow to such a large fleet by hand, right? So if a small fleet is still potentially able to manage in terms of the resources by hand or have a database to source certain information. But how do you know in terms of like which resources is available or which host has the most resources for you to deploy your services? That's particularly really, really challenging to find out where. The second challenge will be monitoring. You could have tens, hundreds, or thousands of individual services. A simple question like, how do you know if an individual service is healthy? How do you measure the performance of an individual services? Or how do you troubleshoot when an individual services actually throws an error? So pretty much it's very hard to know where. Next, you'll be looking at service discovery. Service discovery basically is about how one service learns about another. So for example, if I have a service A that wants to call a service B, how does it know where that service B resides? Right? It has to know the URL. But as the services scale up and scale down, how do you know which host it is residing at? Pretty much you will not have a way to find out. You can dig through it slowly, but you have a large fleet, that's pretty much impossible. And when a new service instance that comes alive, like, hey, I'm up and ready, I'm ready to receive requests, how does it announce to the world in terms of that I'm ready itself? So these are some of the challenges in terms of service discovery. Next, deployment, the same challenges itself. Each development team will have their own timeline in terms of developing their services. Some development teams will have different programming languages that they're familiar with. They're using different frameworks. So these are services are polyglot. And at the end, when the development team has completed their development and built the application itself, how do you decide which host you want to run on? So you need to know in terms of which host has the available resources. So let me introduce you to Amazon ECS. It is a fully managed Elastic service. You practically do not need to run anything. The service scales accordingly to your microservices. You have something called shared state optimistic scheduling. There has been an interesting research in terms of the different schedule type which are more efficient or what have you. So we found out that the shared state optimistic scheduling is one of the more efficient schedules that we have. It is fully ASIC compliant on resource and state management. This is important because in a distributed system, a lot of times databases have eventual consistency, right? So when you want to make sure that you have a view of all your resources at all time, instead of having to worry if there's any consistency issues. Next thing, it is integrated with CloudWatch for your normal monitoring and logging. So if you are used to having CloudWatch to monitor your EC2s, there's no different on how CloudWatch monitors the rest of the services as well. And lastly, if you have DevOps practice in place, you can integrate with the CodeStar services. These are the services like code commit, code build, code pipeline, code deploy. Or alternatively, it can work with some of the third-party CI/CD tools as well. So let's take a look at how the ECS architecture is. So on your left, on the diagram itself, there are two architecture views. On your left, basically, this is your traditional common virtual private cloud, the VPC itself. This is where the cluster will be deployed to. And this cluster will contain container instances. Container instances are basically nothing but EC2. So a cluster itself basically contains a collection of EC2 instances. So within the container instance, there is an agent, an ECS agent, that is communicating with the ECS service. And on top of that, this is where you deploy your containers. There are two types of containers that you probably will deploy. One is a task definition. The other one is a service. I'll get back to that in a couple of slides later. So on your right, this is where the Amazon ECS service resides. So yeah, there's a resource manager that takes care of knowing which host is available, what our capacity it has, what our memory it has, and then within it, there's a scheduler. There are two types of scheduler. One is the task, the other one is service. I'll get back to that as well. So if you want to build an application with Amazon ECS today, so this is a very simple application. So potentially you have one or two or more ECS cluster backed by your data store, could be RDS databases. And typically, these cluster instances or your containers will be fronted by an ELB or ALB, which are the load balancers. And you're potentially using Route 53 to CNAME the FQDN of the load balancers with a friendly URL name. And alternatively, you can use Amazon API Gateway as well to expose certain API services to public, or potentially to be a mobile application. So on your right, yep. So basically, it's the ECS services. It has a repository that for you to push your container images. It has integration with IAM as well. There's a fine-grained permission control and privileges control on the individual service. What can they do? Which service they can talk to, right? So this is a very simple application that you can simply start and do today. You can do monitoring with Amazon CloudWatch. There's a 1-minute period interval of sending the CloudWatch metrics. And there are 4 metrics available: CPU reservation, memory reservation, CPU utilization, and memory utilization. Right, these are the 4 key metrics that you can have on the cluster itself. And you can view it through different dimensions. Could be whether it's based on the cluster or based on the individual service. Dashboard and charge. If you are using CloudWatch to monitor your existing EC2 instances today, this is a very common dashboard and charge that we provide through CloudWatch. This is a service architecture that presents with an ALB to show some of the interesting possibility of using ALB for service discovery. So for example, if I'm not too sure you can see this, basically I have a path, an off path, and a weather path, right? An ALB will be able to route requests based on the path to a target group. A target group basically is a host of servers that is responding to the same type of requests. So based on an off path, I will route it to a certain target group. Based on weather path, I route to a different group of servers. So how does this help with service discovery? So for example, if a service A wants to talk to a service B, service A, what he needs to know basically is just the path information. And if the application is able to construct the URL of that particular path, so ALB will take care of routing the request to the right target groups or hosts. So this is how the service discovery can be automated and updated accordingly. So now, let's get back to the schedule type that I mentioned earlier on. One is the ECS task scheduler. Task scheduler basically is suitable for running batch jobs or potentially a job that you need to run once. Once it's complete, it will exit, right? There are 2 ways for you to run the task. One is called run task. Run task basically, it doesn't care where the host is run. The resource manager will decide based on your requirements of your service, which host it will run. Or similarly, for start tasks, the only difference is that start tasks, you are able to decide which host you want to run on. Okay? The other schedule is the ECS service scheduler. This is for your long-running apps. So for example, if you have an API, REST, or API gateway type of services that you want to expose that keeps running for a long time, this is where you will run your service. It provides health management because it can monitor the service of the health of your service, such that if the service goes down, you want the task to restart itself so that it brings up the service again. It has scale up and scale down functionality as well. It is AZ aware. So for example, if I want to deploy 4 container instances, I do not want to have my container instance to land up in a cluster or host that resides in a single AZ, right? So if the AZ goes down, all my services will be gone. So what I want to do is to make sure that all my container instances or containers are deployed accordingly to the different AZs that I have. Service scheduler also has the notion of group containers. So for example, if I want to have a container that contains Nginx proxy, but at the same time, I want to have a Node.js Express container as well, because these 2 has to work together. So I can create a group container such that every time this service is deployed, the 2 containers will be deployed together at the same time. And here, if you have DevOps practices, this is another use case where, let's say you're using Jenkins, a very common CI/CD tool today. You can actually integrate with ECS. So for example, a developer finished building out the code, check in the code, Jenkins will take out and build the image itself, test the image. It will push to the repository, and it will tell ECS service that I have a new job or a new image being deployed, and I want it to be updated. So this is something that you can do it today, or with Jenkins, or even with our CodeStar services. You can have a code commit such that, for example, if you build your code, you check into your code commit, you do a code build, and based on the code pipeline, I want to use the code deploy to deploy the ECS. So that is something that you can do with pure Amazon services. Similarly for this one. So since you have heard me saying that, okay, ECS will so-called respond to the different challenges that I highlighted earlier on. But many of these tools and innovations is still coupled to a single dependency. So what is that dependency? It's still servers, right? ECS is still a collection of EC2 instances. They are still servers. So with servers itself, it comes with the complexity of that environment introduced. For example, you as an application owner, we have to answer the following questions. For example, like, what type of servers are right for my budget? What type of servers do I need to achieve that type of performance for my application services? So if you are able to do web service or web-based service applications, and based on what you have learned and know-how, what happens if there's no server for you to manage? That would be quite compelling, right? All I have to do is to focus on my application code. I do not have to care about provisioning. I have high availability built in. There's no need for me to patch or monitor the operating systems. So as a developer, I will just focus on my code to build the business logic. And to be serverless applications, it has to be scaled accordingly to what I need as well, such that I do not have to manage the scaling. It will scale up and down automatically. So with that, we are looking at AWS Lambda. So where's Lambda? Lambda basically is a serverless event compute service, right? You can take it as, for example, Lambda being a microservices without server. Here are the different components of Lambda. I'll run through it one by one. First and foremost, this is your Lambda function. The Lambda function basically is a piece of code that you write, right? It could be written in Node.js, Python, Ruby, or even C#. And each code that you write does not mean that it has to be a single function. That function itself can call other functions, can include other native libraries or code libraries that you want. Of course, there's a single point of entry to that particular function itself. Next, the service is what services that this code will have access to, whether it's AWS Service APIs or some other AWS services. Through IAM, you can control that your service, which application that it can talk to, right? It's very fine-grained. You can talk to DynamoDB and RDS, for example. You can fully control that. And last but not least, basically, is the amount of memory that you need to allocate to a function. The memory will dictate the CPU time as well as the network bandwidth that will be provisioned based on the memory that you provide, that you set, for example. Next is event sources. You have built your code. Of course, you want it to be executed. So how do you define when and how it is executed? Basically, it's based on event source. As of today, there are many different event sources that you can do today. It could be S3, it could be Kinesis, SNS, or even Amazon API Gateway. Based on the event sources, there are certain information or data or metadata passed to your function such that the application will know in what context the application code will run. So for example, I want to know, or I want to have my code execute when someone drops an object into an S3 bucket. So I will choose S3 as the event source, and whatever information for that particular action, so for example, who dropped that object into the bucket, what is the bucket name, what is the key and the size of that object, will be passed to the application code itself, such that I can process it. So, of course, the key thing is the AWS Lambda service itself. This is where the magic happens. You check in your code, AWS Lambda will provision it into the AWS Lambda infrastructure. There's no server for you to manage. There's an API for you to trigger if should you need to trigger the API or your function directly. And every time an event sources is triggered, AWS Lambda will make sure that your code is being run. And of course, it provides additional operational capabilities such as CloudWatch integration with monitoring, and there's a logger object as well, such that in your code, should you choose to log a statement, it will go to CloudWatch logs. So you might be saying that, oh, it's all in good now. OK, now I have to do event trigger functions. I'll try to retransform the way my application is being architected. I'll go start to learn Lambda. But however, a lot of times, the team will have decided in terms of, I have decided to go on SOA. Right? So there's no way for me to re-architect my whole infrastructure or application code to make use of event trigger. You can still do it today, right? So this is where Amazon API Gateway comes in. This will allow you to expose your Lambda function as an API. So where's an Amazon API Gateway? You can create your API. Basically, it's HTTPS API. It's support for standard HTTPS methods. What you need to do is configure the API itself, whether it's triggering an AWS Lambda function, calling an AWS service APIs, or even exposing any accessible web services. It could be a web service running in the containers itself or on Amazon ECS. Next, you will publish it. So how do you publish? You can test the API itself before it is released. You can manage multiple stages or version of the API. You can create developer key such that you can expose out this particular API to external developers to leverage on this API to call and use the data that what you provide through the API. Next is maintenance. It scales by itself, right? And the usage is based, the pricing is based on usage. So the number of API calls to that particular function itself. Next thing is monitoring. It is integrated with CloudWatch as well, and CloudWatch logs. And lastly, it is secure, right? It is integrated with IAM, and it uses AWS SIG v4 to authorize access to the APIs. It has CloudFront integration, such that it will help to prevent DDoS attacks. And of course, last but not least, it is able to throttle and cache your API, such that it will protect your backend. For example, to prevent your backend from being the so-called the resources being drained or consumed and bring down the whole service itself. So you can thus throttling to your services. 1 minute. OK, so how would you build such a service then? So a simple one. Quite often, we have in our life, we might have done certain application that converts one object to another object. For example, here, basically, it's from one image to a different format of image or different size. So what I have here, basically, is a function itself. Someone drops an image into a bucket. You trigger a Lambda function, and it will convert that image and return that image to the client itself. So this whole thing, as you see, there's not a single server that you have to manage. I have 1 minute to do a quick one. OK, a simple one. So what I have here, just to run through it, OK, I have an index HTML residing on S3. I expose it out as a website, as a static website. I have an API gateway. This is where the image processing API resides. This is where I configure which Lambda function it's going to talk to. And I have a Lambda function itself. So you can actually look at it for Lambda. You can actually edit the code inline. So for for this one, I'm just using ImageMagick, which resides on the default Lambda environment already. So what it does basically take the bucket based on certain size that you need. I'll convert the size of the image. So let's do a quick one. Let me see. So okay, I have one image here. I'm going to change it to 200. So this is what it does. So look at the whole thing. I do not need a single server. It scales by itself. As the number of requests comes in, it can throttle through the API gateway, and the Lambda function will scale if there's a lot of requests coming in. Another sample that I can give you with is a bot, right? A bot, I can talk to a Lambda function. What I have here basically is a fulfillment function such that you call a Lambda function to fulfill the bot. So same thing here. For example, I have a web bot client here. Let's say I have an internal system that allows me to check leave. So I want to check maternity leave. Well, it doesn't apply to me, but let's try. So based on the bot, based on the Lambda function, basically ask me, OK, there's a certain question I need to answer before it can get back to me. So lawfully married, yes, of course. Worked in Singapore, yes. So let's say it's 15 October. Look at it in terms of just an example how you build all these services without having to manage a single server. So no, I'm not sharing. So I would say, let me just quickly type this. I'm going to start on the same day that it's born. No. So what it does basically, it knows the date, tell you that when you can start, when does it end. So this is something that you can build through a Lambda function without having to manage a single server at all. Okay? With that, my time is up. Thank you.